Hello, my name is Bernhard Marxer from Vector's training department. I would like to welcome you to our video ISOBUS prototype and test development with CANoe ISO11783. On our daily agenda, I will present you some view fundamentals of the ISOBUS protocol in principle. Then I will explain you a typical initial situation of a test project in this context. After that, I will present you an overview or some aspects of simulation and testing in CANoe in general. And after that, I will show you two live demos of a CANoe test environment, of an implement test, first in a previous way, and after that also you will get an introduction and a demonstration of a new testing aspect, also with an implement test. Now we start with our first chapter, some words about ISOBUS fundamentals. In agricultural application, for example, seeding, harvesting, fertilizing, and so on, it is often needed to combine different tractors with different machines from different manufacturers. In the past, each machine brought its own control panel with it, and this must be wired discrete in the cabin of the tractor. The new aspect of ISOBUS is an electrical connection between the tractor and the implement, a standardized electrical connection. In my next slide, you can see this typical component. A central point here in the middle is the IBBC, the ISOBUS breakaway connector. This is a CAN-based connection between an implement ECU and the components of the tractor. You have an isolated bus in the tractor. This is the powertrain, for example. And in between that, you have the tractor ECU, which is distributing tractor information to the common bus, the implement bus. In typical components, for example, is the virtual terminal, or another commercial word is a universal terminal, a task controller, GPS controller, file server, and so on and so on. And the principle is you have a protocol which is handled between implement ECU, for example, a sprayer or loader, or example, and here is our communication. And this situation brings us to our next chapter, an initial situation of a test project. The first use case I want to tell you is a tractor test. In a tractor test, you have arranged some hardware connections to the tractor. You have a full, complete tractor arrangement of virtual terminal, task controller, GPS, and so on and so on. You have test requirements, test data description, and so on, and a test operator, and you await for test reports or test results. What is missing? An implement is missing. You have to arrange an implement, or you have to simulate an implement. Another use case is, for example, an implement test. The same situation, you have hardware components, hardware connections, test requirements, data description, and so on and so on. But what is missing? A tractor is missing. Also, in CANoe, you have the possibility to simulate a tractor, a full tractor, or an implement behavior. And this will bring us also to the next chapter, the features of CANoe, overview, simulation, and testing. A first step is the remaining bus simulation. You have a simulated part, the red one, for example, tractor side. And you have a real part, the blue one, for example, the implement, or vice versa, simulated tractor and simulated implement. The connection between The two sides is the hardware interface, the bus interface. In a second step, you have the test situation, the test feature set of CANoe. In this feature set, you have in principle two options. On one hand, you can create a so-called test module with CAPL, with XML, with .NET, or on the other option, you have the possibility to create test units with a third-party tool from Vector, the vTESTstudio. With both, you can create groups of tests, test cases, and test steps. You can insert commands, test results, verdicts, and so on and so on. And you can integrate the test engine into your CANoe configuration. You will see that in my demonstration, for example, like here. And the test engine runs automatically and creates at the end of a test an HTML test report. In this report, you can see for first if all the tests are passed. This is a general test verdict. And after that, you have a detailed description of all the test steps. And then you have the results. You will see that also in my demonstration, which is followed in the next chapters. In this chapter, I will explain you an implement test on a previous way, on a way with a CANoe with a version less than version 9.0. You see the situation. We have a real DUT, device under test, a sprayer, the implement test. With our REST bus simulation, we simulate auxiliary input, tractor ECU, file server, and so on and so on. We use our task controller, our interactive task controller, and our virtual terminal to interact with the DUT. With the test module, we use CAPL script, and then the test module can influence only the typical ISO11783 node layer functions. The task controller and the virtual terminal must be used by the user on a manual way. We have a test description, we have a test database and so on, and we await a test report and a log file. This is the situation in our first example. Which test steps are typical for such a test? For example, waiting for the initialization of the system. You know, for example, a task controller needs 6 seconds to start up. You have to wait until the object pool is uploaded to the virtual terminal, and so on. This is the waiting for initialization. You have to start the task on the task controller in the next step. You have to set the set points for application rate in the task controller. You have to start the sprayer switch on via VT command. You maybe activate the needed sections, start driving, simulate the vehicle speed by the tractor ECU. And then point number 7, the most important point, check the flow rate of the nozzles. This is the test case. This is a described test case in our test module. Check the flow rate. After the test, stop driving, turn off the sprayer, and the last step, stop the task in our task controller. As I told before, the problem in our previous concept is that we need an instructor to the user, where the test module gives to the instructor, and here have to give the input to this components, terminal, and task controller. Or the other hand is to program all the behavior with CAPL. But this is a high effort of programming, and so I will show you the next concept in the next chapter. But first, we switch to CANoe, where I show you exactly that behavior. Here you see my CANoe configuration. In the simulation setup of CANoe, you see first our sprayer. For this demonstration, the sprayer is also simulated. But in practice, in a real system, the sprayer is connected to our interface and is on a real side of our system. Below, you see the interactive generator, the virtual terminal window, the interactive generator, the task controller window, the simulation of the tractor ECU, and, very important, our test module, written in CAPL. When I switch to our simulation, you see on the left hand a panel which shows you the sprayer changing situation. You see set point of the application rate, the speed of the tractor, and the application rate on injector number 2. In the second demonstration, I will inject an arrow, so you can detect the behavior of the tester. You see the tester interface here. This is the tester engine. In the middle, you see the virtual terminal window, where the object pool is loaded after starting the measurement. And on the right side, you see the task controller window, and also for sure the trace window of CANoe. When I start the measurement, you see that the system is booting up. The task controller is waiting 6 seconds, then it will start up. The object pool now is loaded. And you see that the task is not active. Here on the left side, my tester engine is also stopped at that moment, and I have the possibility to start it here manually. And now I will do the 10 steps of testing as I described before. I start now the tester, and the tester is asking me and wait for system initialization. This has been done after I start CANoe, so I can say yes. Now, please start the task at the task controller module. This I have to do manually. I start the task. The next step is to set the set point, the application rate. I say yes, I have done it. You see now the task is active. And now I go to the application rate settings. I go to the sprayer, see my sections here, and one of the points are the application rate. I have to set the application rate to a value like this. I have to start now in the next step, turn on the sprayer via VT like this, set here the sections like this, and now I can run my system. And you see the sprayer starts spraying. So, like this. Now we are checking for the test. You see the test has been finished. The test has been passed. You see that here. Now we can stop our simulation. And let's have a look into our test report. You see all the steps are fulfilled, and we can have a look at the test report here. It opens. The total verdict or the general verdict said, okay, no problems, the test has been passed. You see information about the tester, the time, the situation, and so on and so on. And here you will get a listing of the tests, an overview, and a little more detailed description. The detail of the details, amount of details here in that report depends on the CAPL program you have programmed here. So the last step, evaluate flow rate, has been passed. You see the flow rate is in a range between 55 and 65, yeah, and you see here 60.6. In my next step, I will demonstrate the same situation, but I will influence the system and I will inject an error so that on nozzle number 2 and flow rate will be 0. So that means let's go back to our simulation. I will restart the simulation and I will inject an error here. Yeah. So, and the rest of the 10 steps, I will do that without any comments, or only less comments. The first step is starting our test module. Wait for initialization, yes. Start the task, yes. Start the sprayer on the VT, okay. Set point, and, sorry, I forgot, set point. Also, application rate. Now start driving. And you see, application rate on injector number 2 is missing. The application rate also here, you can see it is 0. There is something in the injector. And the result will be that the test case hopefully won't pass. Yes, you see it here. Test case has been failed. So I can stop the measurement, go to our test report here and start it again. And you see the main verdict: test has been failed, typical test descriptions, and overview about our test steps. One of these is failed. The flow rate evaluation is failed because the expected flow rate between 55 and 65, our flow rate was 0. This is one part of my demonstration, the previous way to test such a system. In my next chapter, I will show you our new aspects. Here you see the same test again with our new testing concept. What is new? New is that we have, instead of a manual task controller or virtual terminal, for both we have so-called node layer DLLs, similar like the interaction layer. We have an interaction layer for a task controller, and we have an interaction layer for the virtual terminal. We can integrate that in our simulation setup, and then we have a CAPL interface. Yeah? This CAPL interface can be steered from all modules and especially from the test units and the test modules. We have access to panels, graphic window, and so on and so on. Yeah? And the principle is that we remove our interactive task controller and interactive virtual terminal, and we use the interaction layers. In this case, the test modules or the test unit have access via CAPL interface to that interaction layers and can be controlled. So the semi-manually handling of the tests will be full automatically now because we have a remote control to these modules. A test will be operated like this. You have the test module here or a test unit. You have some components of the typical simulated stuff, ISOBUS and the DOT. The following sequence diagram will show that. We stimulate our DOT via test module, via interactive task controller, interactive virtual terminal, and so on. Yeah, this is in one step. In the next step, we wait for the reaction of the DOT. The DOT will answer, and the test module and the test or test unit will evaluate the results directly from the components without any interaction of the test person. So in the next situation, I will show you that in CANoe. We start with our simulation setup. You see here our sprayer again. And now here the very important things. You see the interaction layer for virtual terminal. You see an interaction layer of the task controller, TCEL. You see our tractor ECU. This is the same as before. And you see the interactive virtual terminal, but in passive mode. This is a special option of the virtual terminal to enter a passive mode where the virtual terminal only is listening to the bus traffic. The next, what you are missing here, is the test module. The test module is not realized here. We use, in this case and in this demonstration, we use a test unit, which is created with the tool vTESTstudio. Let's switch to our simulation. Here you see the sprayer settings, application rate, speed, and so on and so on. You see the virtual terminal in passive mode. And on the right hand, you see the sprayer test. It's a little bit more detailed here. The reason for that is that it is a test unit from vTESTstudio. And you see when I start my demonstration that you only have to start the measurement and all the steps will be done automatically. You can follow the steps here by monitoring the verdicts and the time. And if you want, you can see also here the reaction of our sprayer, because keep in mind, virtual terminal and task controller will be controlled automatically by the test unit. Okay, let's start our measurement and follow the 10 steps in our sprayer test window on the right side. Here. After I have started the test sprayer. Here, the same as in the test module, you have a start button, and now I will start it. And please look at here, our verdicts. Wait for initialization, start a task, define the set points, look at here, turn on sprayer, activate the sections, and start driving. Without error injection, all the injectors are working at this demonstration. Stop driving, turn off, and stop the task. And you see the verdict. Everything is okay. The test has been parsed. We can stop our measurement and have a look into our test report here. You see, it's similar to the last one. It's a sprayer test. Overview. You see it's more detailed. We have 10 test steps created. All the tests are passed. The most important test step is here, check reported flow rate. With a link, you can go directly to this, and you can see that the flow rate has been passed, like this. In the next demonstration, you will see the same, but here we inject then there is the same error as before. I start my measurement again, but now I inject the error here. So I can start the test unit here, and please have a look at the behavior with this situation. Test scenario has been started. Wait for initialization. Starting the task. Application set points. Activate sections. And start driving. But be careful. Have a look at here. Injection number 2 does not work. Stop driving, turn off, and you see here, check reported flow rate has a sign that this is failed. You see it also here in the general verdict. Measurement can be stopped. And let's look into our report. The main verdict test has been failed. In the overview of our tests, you can see that 1 of 10 tests has been failed. That means 10% of the executed tests. And in the test result overview, you can also see the check flow rate test has been failed. And with the link, you can go to this test report. Where is it? Here. And the same situation as before. The wrong flow rate has been reported. Flow rate is 0. Expected was 55 or 56. Okay. This was my demonstration of the new aspect of testing. Let's come back to CANoe. Back to our sprayer test unit. If you think you need a high effort of CAPL programming to realize this test function, let me say this is not the truth. I prepared a vTESTstudio test table for you to show you the implementation. Let's go to vTESTstudio. You see the implement test table. And in the middle, in the center here, you see my test functions. Wait for initialization, start a task on the task controller, and so on until the end. Let me show you starting the task. You see the function name and you see the interaction layer application interface. TCEL start task and the name of the network node. Similar to that, you can go to the VT function, for example. The VT function, which is turning on the sprayer, like this. Turn on the sprayer. Turn on the sprayer, you find it here. Turn on sprayer, and the corresponding interaction layer function you find here. VTEL, press soft key. Very important. Press the soft key automatically. VT is the network node and 151 is the object number of the soft key, the key ID, and the duration of the pressure. The function contains pressure, hold, and leave a soft key. Next one, the most important function we have here, our flow rate control. Check reported flow rate. Let's have a look at the implementation. Check reported flow rate, you can see it here. Here is the corresponding task controller function. Task controller interaction layer get value physical. From the task controller, the sprayer is the object, the DDI is 37 from element number 4 and get the flow rate. You evaluate the flow rate in the next condition and create the test verdict. So I hope I could give you a short impression of the application interfaces of the interaction layers. Please note you can use that interface from both sides, from test modules integrated in the CANoe and also test units which are used in the vTESTstudio. Let's come to my last words of today and in this video. I presented you in my first part how to simulate tractor or implement behavior with the ISO 11783 interaction layer of CANoe. In the second step, I showed you a typical test scenario, and especially in the new aspect of testing by using task controller and virtual terminal interaction layers, which are full automatically can be used by test modules or test units. And if you are interested in more informations, you can use our web interface, the Vector homepage. For ISOBUS solution. You can use the following links. Also, if you need more information about the vTESTstudio. If you want to learn more, you can use the online help of CANoe. You can visit our portfolio of trainings on the Vector site. And I hope I could help you and give you an impression of our new testing aspects in the ISOBUS area.